Okay, so today we're going to start chapter 11. Chapter 11 is all about finding circumference and area of circles, as well as arc lengths and area of sectors. It's also surface area of three-dimensional figures like cubes or pyramids, and it's also volume. So you might have already covered this in a pre-algebra class in middle school. So for the most part, the formulas are the same. What might be new to you is going to be the area of a polygon and things like that. But for the most part, it should be, some of it should be a review of, what you've already done. So today we're going to cover circumference and arc length. So let's first define what circumference is. So circumference is the distance all around the circle. So it's sort of like the perimeter of a circle. But because perimeter is only for polygons, this has curved sides, so they call it circumference. And there's two formulas that you can memorize. It's either pi times the diameter or 2 times pi times radius. So two formulas depending on what's given to you. So again, the circumference is the distance all the way around the outside of the circle. That's what circumference is. Now, for the homework for this chapter, when we're doing anything with pi, unless the problem specifies, we're going to use our calculators and we're going to use the pi button. But if the problem says use 3.14 for pi, then that's what you'll use instead of touching the pi button. If it says leave it in terms of pi, then you're just going to keep the pi symbol in your answer. All right, so let's go ahead and see another definition. The next one is arc length. And an arc length is the portion of the circumference of a circle. You can use the measure of the arc in degrees to find its length in linear units. So in the last chapter, we talked about arc lengths, and it was always measured in degrees. So let's think of this arc length that's in red here. Think of this as being like a piece of pizza or a piece of pie. The arc length now is the length of the crust. Think of it like the crust of your pizza. And if you were to cut off the crust and then straighten it out and measure it, that's the arc length. Like if you got a ruler and you measured it. So when they talk about arc length, it's going to be measured in something like inches, feet, centimeters in a linear unit. When we talk about the measure of the arc, that's when we're talking about the arc measure in degrees. Now, the arc length formula is either the measurement of the arc length, that angle or that degree symbol, divided by 2 pi r. Or what we're going to do is we're going to memorize it like this, that the length, not do it in highlight, so the length of the arc, and this is linear units, is equal to the measurement of the arc. And in this picture, the arc is AB. We're going to divide it always by 360 because it's part of the whole circle. And then we're going to times it by the circumference formula. Now, some of the questions are going to say, given the arc length, find the whole circumference. And this would be the formula. But other questions are going to say, find the arc length. And they're going to give you the measure of the arc. And they're going to give you a radius or a diameter. So if they're going to ask you to find an arc length and they give you a radius, then you can use this formula. If they give you a diameter, again, length of the arc is equal to the measure of the arc in degrees divided by 360. And if they give you a diameter, it's pi d. So what we're trying to find is how much of that whole pizza pie is just the crust piece. That's what the arc length is. So it's usually just part of the circumference. So now let's practice using the circumference formulas and the arc length formulas. And let's do some examples. It may not always be arc AB. It could be CD. It depends on your picture. But just know it's the measure of the arc in the picture. All right, so let's try some examples. So this first one wants us to find the circumference of the circle, and they're giving us the diameter length. We're going to do it 2 times, actually 3 times. I'm going to do it leaving my answer in terms of pi. Then I'm going to do the same calculation, but this time I'm going to use 314 for pi. And then I'm going to do it one more time, and I'm going to use my pi button on my calculator. So the formula is the same each time. The formula for circumference, remember there's 2 of them. It's either circumference is equal to 2 pi r or pi times d, which is the diameter. Since they gave me a diameter, I'm going to use the second one. So I'm going to use c equals pi d. Remember, multiplication is commutative. So if you want to memorize it as d pi, this is the same thing. Same thing here with this one. If you'd rather multiply the radius by 2 first and then pi, again, remember the order you multiply numbers doesn't matter. It still gives you the same answer. So for this one, my diameter is 5. So I'm going to replace the d with a 5. So if left in terms of pi, my answer is 5 pi inches. Sometimes on an SAT, that's how you're going to leave your answer, because it may be in the non-calculator portion of an SAT. Then the next time I do the problem, I'm now going to use 314 for pi. So now instead of leaving it as pi times 5, I'm going to take out pi, put 3.14, times it by 5, and this is going to give me 15.7. And again, they're still inches. Let's say instead it says using your calculator's pi button. Now what I'll do is touch the pi button and then multiply it by 5. And then this is going to give me 15.70796. It keeps going. I'm going to round it to the tenths place. So my answer is 15.7. Same answer I got when I just used 314. Because 3.14 is a good approximation for pi. So in the homework tonight, if it doesn't specify, then you're using your calculator and you're using the pi button. Everybody good? If it says use 314, then that's what you do. If it says leave it in terms of pi, then you don't multiply it by 314 or the pi button, you just put the symbol in there. Let's try the next one. Now it's asking us to work backwards for the formula. They've already given us the circumference calculated, and they want us to find the radius. So the formula I'm going to use is circumference is equal to 2 times pi times radius. I'm going to replace the letter C with the circumference they gave me, which is 17 pi. My goal here is to solve for r. So I need to divide both sides by 2 pi. Now you can either do it in 2 steps or just one. I could do it all together. Divide by 2 pi. Notice the pi's cancel. This is canceling, so now I have r is equal to 17 over 2. You can leave it like that, or if it says to round to a certain place, we would divide it, and this divides and gives me 8.5. And these are feet. So my radius is 8.5. So be able to not only calculate a circumference, but also find a radius or a diameter. Everybody good? Let's try some more examples. That one? There you go. Yes. All right, so here we go. It says to find the diameter now of the circle, but this time they gave us a circumference and there's no pi. We're still going to fill it in. So again, I'm going to use the same formulas. And because it's asking me to find a diameter, I'm going to use this formula. I'm going to replace the letter C with a 16. And now I need to solve for D. Notice this time when I divide by pi, there's no pi to cancel it. So if it's said to leave in terms of pi, this would just be 16 over pi. But notice the instructions say to use your calculator and round to the hundreds place. So on my calculator, I'm going to do 16 divided by pi, and I get 5.0929. Rounded to the hundreds place, the 9 looks at the 2, and it becomes 5.09 feet. So in terms of pi, it's this, but rounded to the hundreds place using your pi button, it's 5.09. Everybody good? All right, next one. It's a word problem. It's talking about revolutions of the tire. So for this one, let me draw a picture of a tire. I'm just going to draw a circle. So here is my tire, and it's telling me it has a diameter of 28 inches. Now, when we're talking about a revolution, it's like when the tire goes around in a circle. So what I'm going to do is find the circumference of this tire. And because they gave me a diameter, I'm going to use pi times d. So my diameter is 28. My circumference is 28 pi inches. Now, I need to figure out how many rotations of this tire or revolutions it's going to travel when it goes 500 feet. Now, these are inches, but the distance they want me to measure is 500 feet. So I'm going to convert these inches into feet. And I'm actually going to multiply because they're telling me to use my calculator. So in terms of pi, the circumference is 28 pi. But because it says to use my calculator, I'm going to multiply 28 times pi. And I'm going to round to the nearest tenths place. So on my calculator, I get 5.68. So I'm going to round this to 5.7. Sorry, that is wrong. It's 88, looking at the wrong thing, 88.964. Rounded to the 87. Rounded to the tenths place is just 88. And again, I'm writing the wrong thing. This is 87. So the circumference is 88 inches. I'm now going to convert those 88 inches to feet. I know that there are 12 inches in a foot. So I'm going to divide 88 by 12. And I get 7.3. So in feet, it's 7.3. Now what I'm going to do is to figure out how many turns of this tire, revolutions of this tire, it's going to go around for 500 feet. So I take the 500, I'm going to divide it by the 7.3. And it's going to go around 68.5 times. I'm going to round the 49. So 68.5, so 68 and a half revolutions when this tire travels 500 feet. Yes?
Would the test in the quiz more ask it in terms of pi or rounding the calculator?
Don't know yet. Again, that's way too far away. It's a week. It's not going to be till April, like 30th or something. So it's not next week. It'll be the following. I'll let you know when it gets closer.
And then which one does the homework do?
So the homework doesn't specify, so use your pi button. Okay? So what it says in the chapter, it says see examples 1 and 2, and then over to the side of the textbook it says if it doesn't specify, then use the pi button. So if it specifies, then you do whatever it says.
Can I have the answer for example 1B?
All right. Everybody good so far? Let's go on. Now we're going to do the arc. We're going to do the length of the arc. So remember the formulas for this one. Length of the arc, the formula we're going to use is the measure of the arc in degrees divided by 360, and then remember it's times the circumference formula. And this can either be 2 pi r or pi d. So depending on what's given to you, it'll either be pi d, 2 pi r, or c. So in this case, in example A here, notice they're giving me the diameter and they want me to find the length. So the formula I'm going to use for part A is going to be length of the arc is going to be equal to the measure of the arc divided by 360 times pi times diameter. So I'm going to go ahead and replace the measure of the arc with 75. The 360 is part of the equation or the formula, and my diameter is 9. So actually I could put here, instead of length of the arc, I could put length of PQ. Again, this is the length of the crust. All right, now, normally, when we're not in the midst of a pandemic, we would not be using calculators here. So you would have to simplify this without a calculator. So I'm going to show you how you're going to do it. Now, if you're using your calculator, you could go ahead and multiply 75 times 9 and put it over 360 and then reduce the fraction. Notice this said to keep answers in terms of pi. So what I'm going to expect to see here is a simplified fraction with a pi in it. So I'm going to simplify diagonally here. I can simplify the 9 and the 360. I know 9 divided by 9 is 1, and 360 divided by 9 is going to be 40. So now, right now at this point, I have 75 over 40 pi. I can still reduce this fraction more. I can divide 75 and 40 by 5. 75 divided by 5 gives me 15, and 40 divided by 5 gives me 8. So the final simplified length of PQ is going to be 15 pi over 8. And these are yards. You could also write it as just the fraction, put the pi symbol behind it, and then yards. The pi should not be next to the 8. Yes?
So we're always going to keep it in the fraction form?
You're going to keep it in, so this is, if it says leave in terms of pi, this is what you would do. If it said to estimate the length or round to the tenths place, then what I would need to do, if that's the case, then we would do 15 times pi and then divide it by 8. So let's try that. And if that's the case, we would get 15 times pi divided by 8, and we would have 5 point, and if we round to the hundredths place, 5.89 yards. So again, this is where you're going to need to read, and if it says to leave in terms of pi, you give me this as the answer as a simplified fraction. I don't want a decimal. If it says using your calculator, then you would give me this. Yes. It'll say one of the two. Now, if it doesn't, then you're using the pi button. So if it does not say leave in terms of pi, then we do the pi button. Let's try the next one. The next one wants me to find circumference. So for this one, again, I'm going to be using length of the arc, or length of, this time it's L, it's going to be LN, well, let's just say length of arc, equals measurement of the arc over 360. But since they want me to find circumference, I'm just going to leave it as the letter C. So I'm going to replace what I know. This is the length of the arc, the 60 pi. The measure of the arc is the degrees, and it's the 270. Again, if it says this one, I'm gonna, actually, I can divide this, and I'm gonna leave it in terms of pi, because that's what the instructions said. So left in terms of pi, these zeros will cancel. I can also simplify 27 over 36, and this becomes 3/4. So 3/4 C equals 60 pi. I now need to divide both sides by 3/4. Whenever I see a fraction next to a letter, I know I'm going to be multiplying by the reciprocal. This cancels. And now I'm going to multiply. I can simplify diagonally here. Becomes a 1, becomes a 20. And my answer in terms of pi for the circumference is 80 pi. And this is feet. Now, if it said to round to the hundredths place, then I would take 80, multiply it by pi, we just touch the pi button, and I get 251.33 feet. So this would be the answer using the pi button. This is the answer left in terms of pi. So they will specify when they want terms of pi. If they don't specify, you're using your calculator. Now we're going to do examples and we're using our calculator. Yes.
So for the 4/3 times 60, you would cancel out, not cancel out, but you would divide the 3 and then have the 60 be a 20 and then multiply it by 4?
Yep. Now, since you're going to be using a calculator, but normally we wouldn't, so that's why I would do it like that. Since you guys can use a calculator, you could also just do 4 times 60 and then divide by 3. And it'll still give you 80.
Okay, thank you.
You're welcome. But normally we would not be using a calculator if everybody was in school. Yes?
How do you know what the length of the arc is 65?
It was given up here. It wasn't labeled. It'll be more clearly labeled, but that's the length of the arc. All right, everybody good? We're going to do the same thing. This was supposed to have just been left in terms of pi. I actually showed you both ways. So we're going to do the next one, and we're going to use our calculator. So similar to the one we just did, the length of the arc is 61.26. The measure of the arc is this 270. It's always in degrees. So again, I'm going to use length of the arc is equal to the measure of the arc divided by 360 times the c, because I'm asked to find circumference. So I'm going to replace the length with 61.26. The measure of the arc is 270 over 360, and I'm solving for circumference. Now, technically, since this is a calculator question, you could solve it this way. You could say, okay, I need to get c by itself. I'm going to times both sides by 360 to get rid of that. Get that answer, and then divide by 270. But let me go ahead and do it. And then I can show you another way. Times 61.26. And I get 22053.6. And now it's left with 270c. Divide by 270. And I get 81.68 equals c. So it said to round to the tenths place, so I'm going to make this 81.7. And these are meters. Now, if you want to simplify the 270 over 360, you can do it, but because you're using a calculator, you don't really need to. Does that make sense? Now, if some of you, as soon as you see, for example, soon as I see a fraction next to a variable, I already know I'm multiplying both sides by the reciprocal. 270 times 360. So if you want to do it in just, I'm sorry, it's flipped. You could already flip it if you want and multiply it by 360 over 270. And then that cancels. You're just left with c, and then do it all at once. Times this, and then divide by this. And you still get the same answer. All right, let's try the next one. We're trying to find a radius. So this is the arc length, or the length of the arc. This 150 is the measure of the arc, because it's got degrees. So I'm going to do 10.5 is equal to 150 over 360. And because it wants the radius this time, I'm going to put 2 pi r here. So the part that's going right here is some form of the circumference formula, whether it's the letter c, whether it's 2 pi r, or whether it's pi d. All right, so now we need to solve for the r. Now, I'm using my calculator, so really I don't need to simplify things. I can just start dividing, but I'm going to go ahead and simplify it just so my numbers aren't so big. Whenever I have a 0 in the top and the bottom, I always cut them off. So now I have 10.5 is equal to 15 over 36. And then I have 2 pi r. And again, I'm solving for r. I could also reduce the 15 over 36. Now, if you're worried that you are going to make a mistake and you're simplifying, you could you could also have just multiplied it. Like I could get 10.5 is equal to 30 pi r. And then this is divided by 36. So then what I could do is multiply both sides by 36 to get rid of that. And 36 times 10.5 gives me 378 equals 30 pi r. and then you're going to divide both sides by 30 pi. And we get, and just be careful on this because you might want to use parentheses depending on your calculator. Hold on, my calculator, 378 divided by parentheses 30 pi. And I get R is equal to 4.0107. I'm going to round to the tenths place. So my radius is just 4.0. And these are feet. Now, if you wanted to keep simplifying this at this step here, if we weren't using a calculator, I could reduce 15 over 36. Again, I could divide. So like if I keep simplifying this, I could reduce 15 over 36, divide them both by 3. And then I could also simplify the 2 and the 12, and then get it down to 5/6 pi r equals 10.5. And then it makes it a little bit easier. But again, you're using a calculator. Technically, you could have left it up here and just isolated r with the 150 and the 360 as well. But again, if everybody were in here, we would not be using calculators. You'd have to simplify it by hand. Now let's learn what a radian is. Now, next year in Algebra 2, second semester, we do radian and angle measures. Everybody good on this slide? All right. A radian is just a unit of measure for an angle. What you're used to seeing for angle measures are degrees. This is just another way to measure an angle, and it's called a radian. So when we have a circle of radius 1, the radian measure of a given central angle could be thought of as the length of the arc associated with the angle. And you're going to see a unit circle, and that's where you're going to have a radius of 1. Bottom line here, you just have to memorize the conversion factor. So just like when you convert inches to feet, you know that there are 12 inches in a foot, and that 12 is what you either multiply or divide by. In this case, when we convert from degrees to radians, we're going to take our degree measure and we're going to multiply it by pi over 180. Because what they've shown up here is the circumference, or the whole circle, is 2 pi, and it's equivalent to 360. So this is the conversion, but they simplified the fraction to pi over 180. Once we multiply the degree that's given by pi over 180, then that will give us our radian measure. So for example, if I wanted to convert 10 degrees into radians, I would do 10 times pi over 180. I could simplify, cut off a 0, and 10 degrees is equivalent to pi over 18 radians. If I want to go the other way, from radians to degrees, I'm just going to flip the conversion. And I would multiply by 180 over pi. So I would take my radian measure, and I'm going to multiply it by 180 over pi. So for example, if I have a radian measure, and let's say it's pi over 4, and I want to convert that to degrees, I will take that, multiply it by the conversion. Notice the pi's cancel, and then I just have to divide 180 by 4. This goes, 4 goes in here once, 4 goes in here 45, so it's 45 degrees. Yes?
Is the 10 or is that just an example?
That's just an example. So the formula is just this: the degree measure times pi over 180, or when we go the other way, it's the radian times 180 over pi. So let's try 2 examples on the next slide. Yes?
Can you not have a pi in the denominator? Like a pi symbol?
Yes. Because in a full circle, it has about 6 radians, a little bit more than 6. Because if you think about it, a full circle, the circumference is 2 pi. So if you multiply 2 times 3.14, you get 6.28. So there's a little bit more than 6 radians in a full circle, and you don't need a pi symbol. All right, let's try converting the next ones. Everybody good? All right, so it wants us to convert 15 degrees to radians. So we're going to take our degree and we're going to multiply it by pi over 180. So 15 times pi over 180. So if you just multiply straight across, you would get 15 pi over 180. But I want a simplified fraction. I can divide both 15 and 180 by 15, and this is going to reduce to pi over 12. So this I could cross simplify, make that a 1, make that a 12. And then it simplifies to pi over 12. If I want to go the other way, I take the radian measure, which is 4 pi over 3. I'm going to multiply it by 180 over pi. The pi's cancel. I can also simplify the 3 and the 180 and make this 60. And now multiply what's left. 4 times 60, and it turns into 240 degrees. So that is converting degrees to radians and radians to degrees. In Algebra 2, we will be doing this as well, because the formulas we'll work with are going to be in radians. When we cover this in Algebra 2, we first do the chapter and teach it to you using degrees, because that's what you're used to. Then we do everything all over again, but then we change the units to radians. But the process is still the same, because these are just different ways or different units of measure for angles. Pretty good? Anybody need me to go back to anything?